Welcome everybody to the first lecture in Introduction to Electrical Engineering. So basically, first, before we proceed with the first lesson on Introduction to Electronic Engineering, we need to understand why do we take this lesson. So basically, the main goal of this course is to introduce you to the different branches of electronic engineering. There are different branches, so that you are aware of what each branch do. And based on that, you will select your major. Why is that important? Because you have to select the thing you are passionate about and you love. Because if you study something that you don't love, you will not be motivated, you will not be innovative, you will not be able to create new ideas. So it's very critical that you choose the field you love. That's why we are introducing you to the different types of fields that you can choose in electronic engineering, and you must select and focus only on one field so that in the future you become the expert of this field and you try to transform the discoveries that scientists have made into applications that are useful to the people in your society or in the whole world. So when did electronic engineering start? The main major, it's before 1885, it was sub-branch of physics, basically. And in 1882, it started for the first time ever in MIT and Cornell. In Turkey, started in ITU University in 1934. So it has been like more than around 100 years, electronic engineering around us. So what are the main branches of electrical engineering? What are the fields, the branches that you can choose and study in your major? Electronic engineering is the first one. Microelectronics, microelectromechanical systems, electromagnetics and photonics, telecommunication engineering, signal processing, power engineering, control engineering, biomedical engineering, instrumentation engineering, and computer engineering. Such a comprehensive field. You cannot find all these different majors in any other types of engineering. So it's very critical that you pick one of these and you say, I will be expert in this domain. I will be working in this domain. I will look for the companies who are specialized in this domain. So you understand the importance of this? Each one of you will decide which field he's gonna be expert in. So I'm gonna give you just very brief introduction about each one of them, and then we will move to discuss in details about telecommunication engineering. So electronic engineering involves the design and testing of electronic circuits that use the properties of components such as resistors, capacitors, inductors, diode, transistor to achieve a particular functionality. Suppose you want to design an amplifier, an audio, a recorder, a doorbell, an alarm. All these are basically circuits. You design them, you build them in such a way so that you achieve certain functionality that's useful to you or to the company or to any people anyone who's interested to have and use this application. What about microelectronics? We call it MEMS. It deals with the design and microfabrication of very small electronic circuit components, sensors, for use in an integrated circuit or sometimes for use on their own as a general electronic components. This is microelectronics. Example on this, chips inside your phone, chips inside your computer, wafer design, very small tiny sensors that are integrated in many devices, electronic appliances. Electromagnetic and photonics. This is also another field that belongs to electrical engineering. What does it do? It includes the generation, emission, transmission, modulation, signal processing, switching, amplification, and detection of electromagnetic waves and light. So in the spectrum of light, for example, there are applications nowadays that they use light for sending data from light. You get light, illumination, and you get internet data. Imagine not from the Wi-Fi, from the light. We call this Li-Fi. Not only this, they use fiber to connect the countries between each other. How do you access the website in USA, for example, from here? Do you think that you can access always wirelessly? No, there are fiber optics cable that are connected between the countries, and they carry your data, the data of all the people inside the country here, to the other country, so that you get your web page, or you access a YouTube video, or you access any website that's basically located in a country outside your border. What about telecommunication engineering, which is also another field of electrical engineering? It focuses basically on the transmission of information along long distances over different types of channels. Example, coaxial cable, you transmit your data over a coaxial cable, optical fibers, wireless medium, or free space. The main challenge here is to be able to transmit and receive your data successfully over a long distance. So you need to you need to design and build the transmitter that can prepare the signal in a form suitable to be transmitted over the air. The same for the receiver. You need to be able to design very clever receiver, which is this, the mobile phone, so that it can detect the signal correctly, doesn't make any mistakes. And here the big picture of telecommunication. You have cellular networks, you have Wi-Fi, fixed networks on the ground, and you are having flying drones that provide wireless services in the future. So it includes satellite communication, Wi-Fi, Li-Fi, Wi-Gig, 4G, 2G, 5G, LTE, WCDMA, GSM, Edge, all these technologies belong to communication. So this is basically what communication is. What about signal processing? Signal processing and communication, they are very close to each other. You cannot separate them from each other. If you want to become expert in telecommunication, you must be also expert in signal processing. Because communication in most of the courses, in most of the designs and the problems that you will face in the future if you choose to work in telecommunication, they are related to signal processing as well, because you need to process your signal and prepare it in a form that's suitable to be transmitted over long distances. It deals with the analysis and manipulation of signals to prepare them in the form you want. For example, suppose you want to record your voice. Yes? You want to record your voice, you speak, you generate an analog signal. Yes? But your phone doesn't understand analog signal. It just understands electrical signal. So you put a sensor, which is the mic, that transfers your analog signal into electrical signal. And then you need to transmit this voice. Yes? How do you transmit it? You transfer the electric signal through many components, and you allow it to pass through the antenna, and the antenna transfers that signal into electromagnetic signal that can propagate over the air, over long distances, because electrical signal by its own cannot travel over the air. Yes? Have you ever seen electrical power coming through wireless? No, always with cables. But what if you want to transmit your signal through wirelessly without cables? Then you need to transfer it to electromagnetic waves that can propagate through the air. How does this happen? The antenna. And how do you transfer your analog signal to electrical signal so that your phone can understand it and process it and convert it to bits? Using sensors, mic, or these types of electrical components. So this is basically the processing you will have. You speak here, you generate a signal, and you have a device called transducer. Think of it like mic. The mic transfers your analog signal speech into electrical signal. Electrical signal, you start processing your electrical signal inside your mobile phone so that you prepare it in a form suitable to be transmitted. You modulate it basically so that you transmit it over the air. And then it passes through a front end and then to the antenna, and then it becomes in a form of electromagnetic signal that it can travel over the air, and then at the receiver side you receive this signal with another antenna, and then you process it. The antenna converts the signal now from electromagnetic signal to electrical signal, and then to transducer that can convert your signal back to its original form, which is analog, whether it's picture or video or text or speech, whatever. At the end of the day, you need to see it in its normal form. Yes? So it's very critical and very important, and we use it actually in every day. Yes, you are using your phones every day and dealing with them and this. Now, what about power engineering? What do power engineers do? Deals with the generation of electricity, transmission, distribution, and utilization of electric power. So basically, as you can see here in the photo, here you have a generator that generates electricity, and here you have transmission lines where you distribute the electric power you produced to customers, to their homes. And then you have renewable energy. You produce it from wind or sun or any other natural resources. And you have here sun panels, solar panels that you can use them also to generate electricity, to use it for free without paying for it. For example, in Germany, people, instead of building the roof of your home from dummy material, you just use solar panel to cover the ceiling of your home, the roof, and you use it to generate electricity. So you have electricity to power your electrical and electronic appliances at home, and if you generate more than you need, you can sell it to the network. So basically, you don't pay electric bills there. The government pays you money. Why? Because you are generating and selling to the network. So this is very nice application. Everybody wants to, if you can produce enough electricity and sell it, it's really nice, very good. Now, what about control engineering? Also, there is control engineering. It applies control theory to design systems with desired behavior. It uses sensors to measure the output performance of the device being controlled, and those measurements are controlled and can be used to give feedback to the input actuator that can make corrections toward desired performance. So basically, where do we use control mostly? In robotics. You want the robot to understand very well whether he's doing the right functionality or not. We use it in rocket space. We use it in automobile, cars, planes, devices. So control is very important also and used in many fields. The biomedical engineering, not only control power, electromagnetic and photonics, but also we have biomedical engineering. The application, this domain deals with the application of engineering principles and design concepts to medicine and biology for healthcare purposes. For example, when you go to the doctor and he conduct an X-ray for you, or ultrasonic signals to detect whether you have any problems inside your body or not, or X-ray, gamma ray, MRA, all these are using basically the electrical concepts in order to diagnose you and see whether you have a disease or illness or anything like this. So it's basically a very important field as well that utilizes the concepts of electrical engineering. Lastly, computer engineering. You might be surprised that computer engineering is part of electrical. Yes, computer originally was part of electrical, but because computer is now extremely massive domain by itself, it got separated and they established their own department and this. But basically, originally, it's part of electrical engineering. And whatever you do in electrical engineering, you would need definitely computer engineers to build softwares, program your tools, program your applications in such a way that it gives you the functionality you desire. So it basically integrates several fields of electrical engineering and computer science in order to develop computer hardware and software to use it for achieving certain functionality, of course. So you have the motherboard, the microcontroller, microprocessor, and you have the softwares where you learn to program using, for example, C, Java, Python, C#, PHP, JavaScript, HTML, databases, XML. All these are languages that are used by computer engineers to build applications, for example, mobile applications, web applications, desktop applications. So these are the main fields of electrical engineering. At the end of this course, hopefully you decide and you make your mind which field I'm gonna be expert in, which field I'm gonna be working on for the rest of my life. It's very critical, very important. You choose it, you keep spending your whole life with it. It's as important as marriage. Yes, when you want to marry, you are very careful to select your partner. Yes, the same in your major, because it will stick with you for the rest of your life. So you must be happy with it and love it so that you enjoy it and you stay motivated with it. Otherwise, if you hate what you do, you will always be complaining and not motivated and bored. You don't like what you do. We don't want this to happen to you. That's why we have this course, to decide correctly, and then you just devote your life for this, to become expert in this, and you achieve good things for yourself, your family, your country, and your society. Yes? So what kind of jobs do electrical electronic engineers do? First, you can be a designer, or in a consulting company working, or in research and development, the ones who want to be researchers or scientists, or in companies that deal with test and construction of devices, or in teaching, or in management, or entrepreneur. You want to build your own company. For example, I know students who, when they graduate, they take many courses with us about Internet of Things, about 5G, about modulation, signal. And in their graduation project, they make usually a very amazing project. The company usually gets interested in it, and they tell them, why don't you work with us? Then they sell the product, and then they make enough money, then they build their own company. And they become entrepreneurs because during their education, they were able to develop a very nice device or a very nice application. So you can start selling it, marketing it by yourself. You will become the owner of the company. There are students who did this. Computer software developments, sales or marketing, and the procurements of technical products. You might say, okay, I'm an engineer, why should I work with sales? Why should I work with marketing? But if the product that the company has is technical, nobody can understand or market this product as good as you, because you are an engineer. You know the technical stuff. You know the details of these things, and you know how to put them in simple words so that normal people can understand you. Yes? So you might be in sales. You understand me? Now, let's give you some national companies with electrical electronic engineers. Turkcell, for example. There are more than 13,000 engineers there. Arçelik, more than 19,000 engineers. Aselsan, more than 5,000. Pico, Vestel, Turk Telecom, Turkcell, Vodafone, Tobitak, all these companies, they work with engineers like you, especially electrical electronic engineers. So while you are studying, you can put in your mind in which company I'm gonna be working with, or which company I'm gonna be able to establish or build in the future, about which product. You will be able to answer this question during your studies. But the most important single point is to choose what you love, to choose what you like, what you are passionate about. Now, these are the national companies, but I can also work in international companies like Facebook, Google, Apple, Microsoft, Amazon, Uber. All these companies are open for you. For example, Google has more than 60,000 engineers. Nokia, Finland, more than 62. Intel in USA, Dell, Sony, IBM, Apple, Samsung, Foxconn in China, more than 1 million engineers. So imagine the opportunities for you are huge, but you need just to be really, really motivated and work hard to be expert, because if you are not expert, I mean, engineering is very, it's difficult if you don't put your mind in it and you don't invest in it and you don't follow up with it. Becomes difficult. But if you study every day and you work on it every day and you follow up with your courses and you even read beyond your courses, it becomes very easy for you, and you start enjoying it. It becomes fun. You understand me? When it becomes fun, if you put time for it. But if you just study at the time of the exam, you will not feel that you are an engineer. So you must study regularly and prepare and study even beyond your courses. So with this, we conclude our lecture for the Introduction to Electrical Engineering. And if you have any questions, you are welcome to ask so that I answer you. And after that, we can move to the details of Introduction to Telecommunication, because this is my field. I need to talk about it in details. Thank you very much.